All right, let's finish off. We're going to be talking about humans and pollution to finish off Unit 1. We're going to start, once again, by doing some vocabulary, and these are word parts that we're going to be seeing, especially maybe some suffixes. This ion ending, right? ION ending means a state or result of an action, whereas ANT means kind of someone or something that performs an action. It typically forms a verb. The two examples that we have on the right here, pollution and pollutant, right? So to pollute, which is adding a harmful substance to an environment, then ION, if you put them together, is the result of adding a harmful substance to an environment. Whereas a pollutant is something that adds a harmful substance to an environment. So the pollutant is basically the thing that pollutes, right? So it becomes a noun. Okay, so we'll be seeing both words often in our course, but just wanted to point out the slight difference there. Also, we have able, which I'm guessing you can figure out, right? So it's like able to, nungo. And then we saw it in actually the last unit on sustainability, sustainable, able to be sustained, right? But we're also going to see it in the future in different situations. So we see here I have this example, biodegradable. If you see this word, it might be a little bit confusing because you might not know what it means. But then you break it down into parts. We see bio at the beginning. Bio means life. Degrade means to break down. And able, which means able to. So if you put it all together, you end up with able to be broken down by life. And I made a typo there. It should be able to. But yeah. So you can kind of guess the meaning of a word. So able to be broken down by life. So really that is, and we'll talk about it later, it's kind of these organic substances that bacteria and decomposers can break down easily, and other things like the sun, right? And then this prefix in. So this one actually has two different meanings, which makes English very confusing, but we'll see both in this course. One of them is inside, which you can guess. And then another one would be or not, or or another one would be not, right? So sometimes, so if it's like inside, you can think of like inhale, to breathe in. Inhale. That's one scientific word that we use for that, and we're going to see another one later on in this chapter as well. But we're also going to see it used as not, and I think we'll see that in this unit as well. I'll point it out. And then these are some words that we'll see. So one is contaminant. We see that ANT ending again. So that means, it is the thing that causes something to happen. But really, contaminant is the same meaning as pollutant, right? They will be used the same in this course. So sometimes we will say pollutant, sometimes we will say contaminant, sometimes we will say pollute, sometimes we will say contaminate. So these two words are synonyms. They are interchangeable. And then we have this word organic, which in a scientific way is really it's a substance obtained or produced by a living organism, and it will have carbon bonds in it. That's kind of the basic part of being organic, is it has carbon in it. This is not a chemistry class. We're not going to go too deeply into it, but typically when you think of organic, you think of carbon, right? And also, typically when you think of organic, you think of living materials and living organisms. Okay. I did this. Oh, I need to change that. That's my mistake. I'll change that after. And then let's go over significant idea. So Pollution is when humans add something harmful to the environment. It happens when this harmful addition is faster than the environment can sustain or handle, and it has a noticeable effect on the organisms in the environment. Okay, so it's really when the pollution is unsustainable, right? So that's what that second sentence is. It happens when this harmful addition is faster than the environment can handle. So if it's just too much and the ecosystem cannot sustain it, then it is considered pollution. So I think we understand the idea, but that's kind of the idea that the IB would like us to know, right? That's the definition of pollution. Now let's really this unit is going to be a lot of definitions, right? So we're going to talk about types of pollutions, characteristics of pollutions, things like that, and there's going to be a lot of memorization. So maybe not the most interesting unit, but hopefully very useful, especially for future units to understand maybe what we mean by biodegradable or persistent pollution, right? But we'll go through it. And then also, just as a note, at the end, there will be a part that is generally pretty important. So it's not all definitions in this unit. There is a portion, a concept that typically ends up as like a common question type on an essay portion of the IB exam. So if you stick around for it, you will learn something useful as well. All right. So, but we're going to start out with definitions, types of pollution. First, we see this word again, organic. So organic substances. So these. So again, we're talking when we say organic substances, we're talking about kind of organic pollution. This whole unit is about pollution. So in this case, this is pollution originating from living organisms. Okay, the examples might be agricultural runoff. Okay, domestic sewage, volatile organic compounds, which we'll learn more about in the atmospheric systems unit, and waste discharge from industrial plants. Okay, so the key point here is a lot of these come from living organisms, right? So we see in this picture, it's not a pleasant picture, but when an animal dies, it doesn't go away on its own, right? It needs to be broken down, right? And typically bacteria will break it down. Additionally, there is fertilizer and natural from we're talking poop and things like that, right? That is coming from farms, things like that, and domestic sewage, which is being broken down by bacteria and decomposers. But it is a form of pollution. It's something that's added to the environment, sometimes at a rate that is not acceptable, right? It's too much. So that sewage needs to go somewhere. Okay? And then we have inorganic substances. So inorganic, so this is, again, that prefix in this meaning, it means not. So not organic substances. So it's the opposite. So this is pollution coming from chemical substances such as metals, acids, bases, salts, and other mineral-derived compounds. Okay? They can come from industrial discharge, mining activity, and runoff from urban areas. And I think one big point to make here is that inorganic substances are harder to break down, right? They will stay in the environment much longer. So they tend to be a bigger issue. So when metal gets into the soil or when metal gets into the water supply or into the ocean, it's harder for it to be removed naturally. Okay, it will stay there for a long time. Same thing with things maybe like plastic, for example, right? That will stay for a long time. But we'll talk about it when we get to persistent pollution. But yeah, these metals, acids, bases, and salts, these are pollution that is more of a problem. Whereas organic substances, they can be more easily broken down by bacteria and decomposers, and it goes away much quicker. So it's less of a problem than inorganic substances. Additionally, we have other types of pollutants, one of which is biological agents. So biological agents are organisms or toxins that can cause diseases and health problems in humans, animals, and plants. They can be bacteria, viruses, parasites, or fungi. Sources include agricultural runoff and industrial waste. They can contaminate soil and water. So this is also something that kind of just the ecosystem maybe doesn't want or need, and if we put too much of it into the soil, it can cause problems. It can cause disease in plants and hurt the ecosystem, right? So we tend to want to be careful about this as well. It's maybe something we don't think about too much. We typically think about pollution in other ways, but this can also be very harmful for an ecosystem, right? If it can't fight off these biological agents, it can cause issues. Okay. Now we have another type of pollutant, which is invasive species. So again, we have this in prefix. In this case, it means inside. Okay, to invade, right? So to go into is kind of the meaning, right? So these are species that are not native or normally found in an area that go into a new area. And we're going to talk about this a lot more in Unit 3.3, but sometimes humans will introduce non-native species to areas. This has damaging effects on the local ecosystem, sometimes causing ecosystem collapse and animal extinction, right? So we see in this chart on the left, we have known causes of animal extinction since 1600, and we see 39% species introduction. That means invasive species. So imagine, let me think of an animal that's not native to China, right? If we brought a grizzly bear, a very big bear, into China, that might destroy some of the ecosystems here. And same thing if you brought a tiger from China into America, right? That those are extreme examples, but it could cause. They have no. They have kind of. In some cases, no enemies. In some cases, nothing to check their numbers, so they grow and grow and grow, and it causes extinction of other species. Maybe a more easy to understand example is rabbits. If you introduce rabbits into an area and there's no predator for the rabbit will grow in number, and all of a sudden they will eat all the grass in the area and all the food, cause lots of harm, and that will cause, eventually the rabbits will die themselves, but also the ecosystem will collapse. And that will cause lots of extinctions. So that is not a good thing, right? So we tend to think of invasive species as a very big problem. And often invasive species come to new areas because of humans. Humans introduce, sometimes we like it for cosmetic reasons, which means we think, oh, this plant is so beautiful, I want it in my yard. Well, it causes problems once it spreads, and it outcompetes some of the other native species and causes ecosystems to get unbalanced, goes out of equilibrium. Again, we'll talk about it a lot more in future units. I don't want to go too much into it. Another type of pollutant would be light, sound, and thermal energy. And again, we saw this vocabulary word therm, which means heat. So thermal, ol is like pertaining to, it's about. So it's about heat. So light, sound, and heat energy is kind of the meaning, right? So we don't think about this often as a type of pollution, but they affect ecosystems and they affect animal life, and they can really harm animal behavior. So all three can affect the behavior of animals. Light can affect navigation and disorient migratory species. So imagine a bird flying at night and they're expecting to see the stars, but they see lights and they get confused. Same thing happens with moths and mosquitoes. Mosquitoes like Wenza, right? Um, uh, their behavior gets changed by the presence of light. So us putting so much light into the sky can cause problems for the behavior of animals. Okay. Additionally, sound can interfere with communication and navigation. So we have here the example on the right, maybe whales. It affects their behavior, right? They use sonar to get around, and it will confuse them and maybe cause their behavior to change in a negative way. Additionally, heat can disrupt reproductive behaviors, cause animals to find new habitats, and affect the oxygen levels in water. So sometimes animals so this lower left-hand corner, animals are looking for a specific temperature to mate, to have children. And if there's an artificial source of heat, maybe from a factory or plant discharging, then that could change their behavior. Again, animals might leave an area if it gets too hot or too cold. And then it'll affect the oxygen levels in water, which obviously is a bad thing. Fish need oxygen, right? So let's go into sources of pollution now. Okay. So, okay. Before we go into it, really, there's maybe the way that we talk about it in day-to-day life, right? So if you were to ask a person what's the biggest source of pollution, we would say like, oh, humans, right? Or factories, or cars, right? These are big sources of pollution, and that's all true, and that will be true for the point of this course. But maybe in this course we also need to learn some vocabulary, maybe scientific vocabulary. We classify these sources of pollution in different ways. So we need to learn some new vocabulary for these sources of pollution. So again, we start out by talking about human activity. So the majority of pollution comes from burning of fossil fuels for power generation, industrialized plants, and automobiles. Other significant sources include agricultural activities, deforestation, and waste disposal, as well as residential and commercial activities. Okay, so humans. Humans are a big source of pollution, and again, that's a big point. And again, these sources, human sources of pollution, can be divided into two categories, which we're going to talk about: point source and non-point source pollution. So point source pollution is pollution that arises from a single clearly identifiable site. Okay, so we see this picture. It's very easy to see where the pollution is coming from in this picture. It's coming from this pipe, which probably is coming from either a sewer or from a factory, right? It's discharging waste into the water. So if we want to fix the problem, we can identify very easily where the problem is. So point source pollution is very, it's easier to manage and easier to regulate through direct action. Whereas non-point source pollution is pollution that comes from many different sources. It comes from many different places. Okay, it's harder to control and requires comprehensive interventions such as community-wide education and management programs. So again, we have here like maybe a river or the ocean, and maybe runoff. Runoff is like a kind of maybe if think of it like rain pulls the water. Um, uh, when it rains, the water has to go somewhere. Well, it goes into the river, it goes into the ocean. Well, it is not. It's not going there completely it's not going there in a pipe. It's not going there cleanly, right? When it hits a city, right, it's going to hit maybe oil that's discharged from cars. When rain happens in a farm, it's going to get some fertilizer and chemicals from that farm and take it to the river. From your house, you might have some chemicals that you use to wash your car or something, right? So all these different chemicals get pulled into the river, and it's hard to identify or hard to regulate because it's coming from so many different places. So the kind of needs a more comprehensive or fuller solution to the problem. Okay, so maybe it just is education programs to change human behavior, or maybe the government needs to get involved in more comprehensive ways. Okay, now we're going to talk about some characteristics of pollutants. Okay, we already kind of touched on this, but we're going to talk about persistent versus biodegradable pollution. So, persistent pollution is pollution that stays, right? So, persistent pollutants are chemicals that resist environmental degradation. So, that means they are hard to break down. Examples include plastics and pesticides. So, that's why we have this picture on the left. Plastic is a big issue with waste. It just stays forever, right? It's not forever, but for a very, very, very long time. So, us using so much plastic in our day-to-day life is an issue. Additionally, pesticides. I used to know the Chinese word for this. Is it nongyao? I think it might be nongyao. Nongyao. These are chemicals that that will harm the farm, right? Or they will kill bugs on a farm. That's actually, if we break it down, pest in English means bug. Icide means to kill. So these are chemicals meant to kill bugs. Okay, but these chemicals stay in the environment for a long time, in an ecosystem for a long time. So they can accumulate and persist in the environment for long periods. We can also get more specific. So we have persistent organic pollutants. They are a specific subset of persistent pollutants that are organic compounds with high resistance to environmental degradation. So they're like a special type that are organic and have a high resistance. So some examples of this, we have PCBs. We could find these in electrical transformers and capacitors. It's hard to translate the idea of this into Chinese, but it's basically electronic parts, right? Big electronic parts, as well as in paint and in lubricants. So they will persist in the environment for a long time. DDT, which we'll talk about more in a second, is a chemical that we use as a pesticide to kill mosquitoes. And then dioxins, this is also another very potent issue, and it's a byproduct of herbicide production and bleaching of paper and other sources, which we'll talk about later in this class. But they have health effects and they stay in the environment for a long time. They are very potent and not good. So all of these are especially bad. Okay, persistent organic pollutants. Biodegradable pollutants, like organic waste, naturally decompose through microbial action. They have less lasting environmental impact and break down relatively quickly. So you think of food waste is easy to break down by bacteria. It quickly is changed into a usable form, right? So these are not as bad of a problem. So persistent pollution is a big issue. Biodegradable waste is much preferred, right? So if we had the choice, we would definitely choose biodegradable. So that's why Many companies are trying to switch to biodegradable packaging, and many consumers, many people are trying to pressure these companies into using biodegradable products. Okay, so let's talk about DDT. So this is a special case, kind of a famous case, and it shows the dilemma that we have in science, and where sometimes there's advantages and disadvantages to a problem and or to a substance. So in this case, uh, we'll try to say this word: dichlorodiphenyl trichloroethane, right? It's a very long word. You don't need to know it. You just need to know DDT, right? Nobody knows this long word. This is a chemical, basically. You need to know DDT, right? So the name of it, DDT, uh, it is... So DDT has some good purposes, but it also really hurts the environment. So that's the dilemma. That's what we need to understand. You don't need to know too much in detail, but you need to know that there's this debate about DDT, and the debate is over its usefulness versus its harm, right? And it's been such a debate that, it has been banned and then unbanned, and then, there's been debate the entire time it's been used. So we'll talk about it. So DDT, before 1970, DDT was used widely as an insecticide. Again, we see this suffix "icide" means to kill. An insect is insect, bug, right? So it was very effective against mosquitoes carrying malaria. Okay, so it's hard to describe what malaria is, right? Unless we get the translation. Hopefully I got the translation here, right? So malaria is a disease very common in China, or not China, in Africa. It's been speaking too long. It's been my words haven't been coming out correctly. I've been misspeaking. So it's a very terrible disease, very common throughout the world, and DDT was very effective in containing its spread because it killed mosquitoes. Mosquitoes were the ones that were spreading malaria. So it was very important for this battle, right? But then Rachel Carson, in her book Silent Spring, outlined the environmental effects of DDT on birds. And as such, in 1970, it was banned by the World Health Organization, or WHO. Recently, DDT was exempted from the ban, which means there are situations in which it is allowed to be used, again, because it has utility. And in LEDCs, these poorer countries, low economically developed countries, DDT is being used to spray walls and furniture to keep these mosquitoes out and thus keep the disease away from families and things like that. Okay, so again, it was banned and then kind of unbanned in the last 60 years. So there has been definite debate. So let's go over some of the pros and cons of DDT. So the pros is the fact that it's an effective way of controlling malaria. So that will save human lives, right? In 2022, malaria killed 600,000 people, right? That's a lot. That's too many. And there were 249 million cases worldwide. To put that into perspective, the United States is maybe 340 million, 350 million. So maybe imagine if 2/3 of the United States got sick with a deadly disease every year, right? That's how common this disease is. And what's more tragic is that 80% of the deaths were children. So this primarily affects places like Africa, where countries are still developing, and this was a solution. So this third positive point is that it was cheap, it was very affordable in these poor countries where malaria is very common. So yeah, uh, there's obvious positive use of DDT uh, to deal with mosquitoes. So uh, that's why we kind of unbanned it. We kind of allow it, but there are definite cons. It's not all positive. So one is that it's very persistent in the environment. It's very hard to be biodegraded, and it will accumulate in the food chain. So um, if one animal eats another one, and we'll talk about this in a future unit, but basic idea is if one animal eats another animal, if that animal had DDT, then the animal that ate it will also have DDT. It will stay in the food chain. Each animal that eats another animal will keep that DDT, and it will accumulate as it goes up the food chain. So that's bad, uh, especially for us as humans because we're at the top of the food chain. So it will accumulate and grow and come to us as humans and cause health effects, right? So that's bad. Uh, and it affects certain species more. So, Silent Spring talked about birds. In particular, we have the example of bald eagle. Um, so bald eagle, that's this bird here. Um, its population used to be 300,000 to 500,000. That was in 1700. And then by 1970, by the time the ban happened, it was down to 500. And what happened is uh, DDT was thinning the shell of the egg. So the egg was not surviving, right? So the child, the baby bird, the baby bald eagle was not surviving. So when that started happening, it's mostly the result of DDT. Once DDT got banned, the bald eagle population started to rebound. Again, we'll talk more about this. This is an example of, intervention that was very successful. But again, another discussion for another day. And then the human health effects. One is cancer, reproductive issues, blah, blah, blah. Not good. So again, we're at the top of the food chain where DDT will tend to accumulate, and it has bad effects on humans. So again, pros and cons. For the purpose of the exam, you definitely probably need to know about the debate. You don't just need to know that it's bad, you need to know that it is also good. You need to know both, okay? Now let's talk about acute versus chronic. So if you know these English words, it's probably easy to understand what this means, but maybe you don't. So acute means like sudden, okay? Something suddenly happens, kind of like an emergency in this kind of meaning, acute. Whereas chronic means lasting for a long time, okay? So it just happens and it doesn't go away. So acute pollution refers to sudden, severe pollution events that cause immediate harm to the environment or health, such as oil spills or chemical leaks. So when a boat crashes and spills all its oil into the ocean, that's terrible. Affects the ocean ecosystem quite a bit. And that is a severe, sudden problem. It happens quickly and it solves itself relatively quickly, depending on the problem, but it's not something that lasts for years and years and years and years. Just kind of a one-time event kind of thing. Chronic pollution, on the other hand, is long-term, less intense, and often goes unnoticed for extended periods. It includes ongoing issues like urban air pollution and continuous agricultural runoff, leading to gradual environmental degradation and health problems over time. So, again, maybe humans didn't realize the harm that we were causing to the environment by burning coal and polluting the air. It took a while for us to kind of figure that out, right? The effects of it. but we were chronically polluting it. It went unnoticed that the effects were happening, right? But the basic definition is that it's a pollution that happens for a long time. The example I have here on the left is a factory. It's just going to, until the factory closes, it's going to continue polluting the air into the future. Okay? Now, let's talk about primary and secondary pollutants. Okay? Maybe, so a hint, if you know these words, then it might give you a hint of what the meaning is. Primary is the first, secondary is second, right? So these kind of explain a little bit what these type of pollutants are. So primary pollutants are directly emitted from a source, such as carbon monoxide from car exhaust or sulfur dioxide from factories. They enter the environment in a harmful form. Okay? Secondary pollutants, however, are not emitted directly. Instead, they form in the air when primary pollutants react chemically with other elements, like ground level ozone forming when vehicle emissions react with sunlight. Both types can have serious health and environmental impacts. We will learn more about this when we talk about atmospheric systems in Unit 6.3. But basically, the point is, so some chemicals go into the air, and they are pollutants right away, right? They affect the environment in a negative way right away. But there are some pollutants that are formed by a chemical reaction while in the air, because all these chemicals are bouncing off each other or they're getting hit by the sun, and they're forming new chemicals, and as a result they form a entirely new pollutant, which is a secondary pollutant. So it's not coming from maybe a pollution source on the ground, it's coming from these primary. So the primary pollutants go into the air first, and then they kind of react with each other, and after those reactions they become secondary pollutants. These are the result of these reactions. Okay? And we will discuss this a lot more in Unit 6.3, this whole process, but the point is that they're both bad, but they are a little bit different. Okay? Okay, we got through all of the definitions. Now we're at the part where, so this is something that will commonly show up on the essay portion of your of the IB exam, and this is something that we will use to discuss pollution management in the future in this course, right? So this is something that pops up a lot, and it's a way that we kind of view, like, how do we solve the pollution problem? That's a question that we're going to discuss in many units. So we're going to talk about water pollution, air pollution, soil pollution. Well, how do we solve these problems? Well, one way is to use this system, which is called the 3 levels of pollution intervention. It also might be called the 3 levels of pollution management. So it can go by either name. You can see either on the exam or used in my class, right? So this is the chart. So the IB actually provides this chart. So you should be familiar with this chart. And it basically shows the 3. So at the top here, this is the first level. This is the second level in the middle, and then the third level at the bottom. And the point, maybe the major point to know is that this first level is most effective. This is the second most effective, and this is maybe third most effective. It's not as effective as the first level. And we should do all 3 because all 3 will help the problem. But if at all possible, we should try to do the first level, which, as we see, is altering, preventing pollution or altering human behavior, right? Altering human activity. Okay, so The ways we do this is first by campaigns. So campaigns are like these short events to encourage people to live sustainably or pollute less, right? So anti-plastic use campaigns or car-free day events. So this is trying to convince people to not use plastic for a short amount of time or to not use their car for a day, right? Or energy conservation awareness drives. So sometimes we'll say, oh, it's the summer, it's hot, so try to conserve your energy. Uh, this week is a surge event. We have this in California. Um, there's going to be a surge of energy usage. We need to conserve our energy. And that is a way to alter human behavior, right? To prevent the pollution from happening in the first place, right? So that is good, right? That's maybe the most effective, along with some of these other things that alter human behavior. Another one is education, school recycling programs, university sustainability workshops, and public seminars on environmental impact. So think of it as like classes on environmental impact, right? So if we teach people about the importance of recycling, sustainability, and environmental impact, their maybe their carbon footprint, things like that, then that will change people's behavior for the better. So that is good. That is very effective. Community groups, also very effective. Okay, so people coming together in a local area to, for example, clean up the local river or the beach. Okay, and maybe they get together often to clean up the local area, to clean up a river or a beach. Or they will plant trees together, or they will start a neighborhood recycling initiative. Now, you might have the question that many people have, which is, what's the difference between a community group and a campaign? They seem to be doing the same thing, and maybe one big difference is the time, right? So a community group is something that could last for a long time, could last for several years. So maybe a group of people get together every week to go clean the local river, right? So that would be a very helpful thing. It lasts for a long time. Whereas a campaign might be like, it's the yearly river cleanup event, right? So it just happens for 1 week. So the length of time is very important. So a campaign is like an event. A community group is a group that stays together and helps to prevent, manage pollution, and solve environmental problems together for a long time. Another important thing is government legislation. So this means government legislation to change human behavior. So it's specific government legislation. So that's emissions limits for factories, restrictions on waste disposal in natural habitats, and laws mandating green building practices. Okay? And then finally, economic incentives and disincentives. So this means to give people money or to take money away from them. That's the meaning of incentive and disincentive. So a subsidy for renewable energy use. So if you use renewable energy, they will give you money. They'll give you a subsidy. That can go to private citizens or it can go to business. Tax rebates for electrical vehicle purchase. That's a common program. We see that in America. Okay, it encourages you to use electric vehicles and not gas vehicles. And then fines for exceeding pollution thresholds. Okay, so that is taking money away from you if you pollute too much. So all of this is probably the most effective strategy for managing pollution. Okay, so this first level, it's about preventing pollution before it happens. It's about changing human behavior to live in a more sustainable way. And that, in the big picture of this course, that's maybe one of the bigger lessons to take away. It's better to prevent a problem than it is to clean up the problem, than to fix the problem. It's much more effective. And that's kind of what this 3 levels of pollution management is talking about. And by the way, this is it in Chinese. You can pause the video and see what it says, right? So the first level is the most effective. That's the main point. Okay, so if you ever get a essay on this topic, you might want to mention that fact that the first level is the most effective and efficient way of managing pollution. But people aren't perfect, right? And we sometimes pollute, and sometimes we need to create things like we need to improve the economy. We don't yet have the technology to completely create things without pollution byproducts. So in that sense, we need to control the release of the pollution. So if we can't change human behavior, the next step is to minimize the amount of the pollutant that is released, to control the amount of the pollutant that is released. So this is the second most effective solution. So this is level 2. The first part of it would be legislating and regulation. Don't like that English. Legislation and regulation. Legislating. Yeah, I don't like that's unclear English, but legislating, period, and regulation standards of emission. No? Yeah, I'm getting lost in it. But basically, creating standards of emission and legislating for these standards of emission, right? So, for example, vehicle emission standards. So, your car releases these this terrible pollution from it, okay? And some countries are very good at having standards for it, and some countries are not. They have higher standards or lower standards. So I know in my state, California, we used to have lots of air pollution. It was very well known. California was known for its air pollution. It called it smog, right? And that largely came from our usage of cars. Lots of people use cars in Los Angeles. Eventually, California, the government, put in laws that forced you to limit the amount of pollution that comes out of your car. And every year, you have to go and get your car checked for the amount of pollution it's releasing. And ever since then, the pollution problem in California has improved. And I can tell you that from experience. It used to be really, really bad. Now it's a lot better. Maybe not perfect, but better. Industrial emission limits for sulfur dioxide and NOx. Okay. Regulations on agricultural runoff, such as fertilizers and pesticides. Okay. Now, again, the point here is that we're still using these technologies. We're just limiting the amount of pollution coming from them. So we're still allowing cars to exist, but we have a standard that minimizes the amount of pollution that cars can release. And that helps the problem quite a bit, right? And then limiting the amount of industrial emissions, right? So we still want factories, we still want the economy to run, but we need to limit the amount of pollution that is released. And then the second solution here would be developing or applying technologies for extracting pollutant from emissions. So this is, again, kind of like a way of limiting the amount of pollution that's being released. So you do it as it's being released to minimize the amount of pollution that's being released. Okay, so we'll probably talk about this more in different units, but examples are scrubbers in factory smokestacks for gas removal. So factory smokestacks, these are these things, these, well, we had a picture of it earlier. Where is it? Like this, right? This is a smokestack, right? It releases pollution into the air. So we can put technology in those smokestacks to kind of limit the amount of pollution that's released, right? Additionally, we can do carbon capture and storage at power plants, which is a technology that we will talk about as kind of a sustainable solution to this problem. And then advanced wastewater treatment for contaminant removal. Again, these are all just technologies that we use to remove the contaminant or pollutant from the emission. Okay, and this is it in Chinese. So again, you can pause the video, read it before we go on. All right. Finally, we have the third stage of managing pollution. So sometimes the world is not ideal. Sometimes we have too much pollution. Well, what we do in that case is to clean up and restore these ecosystems. So sometimes the ship crashes and spills oil. Well, we have to clean up the ocean as much as we can and restore the ocean ecosystem as much as we can. Sometimes we have damaged the ecosystem beyond beyond the point where it passes the tipping point, and we need to kind of try to bring it back to health. Okay, so this is the last step. It's the least helpful, least effective, but it's something that's still very important. We shouldn't just ignore the problem once it happens. We should actually try to fix the problem. So the first part of that would be extracting and removing the pollutant from the ecosystem. So this can include cleanup operations for oil spills in oceans and seas, just like I mentioned, removing heavy metal and toxins from contaminated soil, and purifying polluted water bodies through bioremediation techniques. And again, we see this bio, we know that it involves life, right? And then remediation, kind of like to fix something, right? So this, you can, if you didn't know what this word means, you can kind of guess the meaning just by looking at the word part, and we see that ION ending as well, right? So this can be done through technology, right? So technology can be used to remove pollutants from ecosystems. Additionally, just human effort can be used to remove pollutants from the ecosystem. So that is one strategy. And then also replanting or restocking lost or depleted populations and communities. And I probably should have included this to our word parts, but re means again. Okay? So to replant, to plant again. So if, for example, a plant has been harmed, well, we will plant a new plant. We'll put a new plant in its place to restore the ecosystem. Or restocking, which means kind of like adding new life into that area. So if a population is depleted, either a plant population or an animal population, we can try to fix that. So here we see that again, reforestation projects. So to make a forest like new again, right? In areas affected by deforestation or wildfires, restocking fish in lakes and rivers that have suffered from overfishing or pollution. So that means putting new fish into the lake, okay? Or reintroducing native plant species in ecosystems where biodiversity has been lost. So adding those native plant species again into those ecosystems to help them with biodiversity. So this is a way of trying to solve the pollution problem, a way of managing pollution. We will talk about this a lot in our course. So this is just like an introduction to it. We're probably going to, and probably in your classes, you know, whatever class you're taking, you will be seeing efforts to solve these pollution problems using this structure, right? The 3 levels of pollution management or 3 levels of pollution intervention. Okay, so if I am correct, this is the end. Yes. Okay, so we'll finish it off there and come back with unit 2. Okay.